Last video we talked about this two, right? Positive feedback and negative feedback. So this video we talk about gyrator, and this is my second attempt doing that because it was a fucked up video. Anyway, so hopefully this is not fucked up. So gyrator is an op-amp circuit that replicates many of the user's characteristics of an inductor. So this is actually a low pass filter. So I'll just explain using this thing to let you understand what is the low pass filter and the behavior of the inductor. So after which then you can understand what the hell is this dude over here. So hold on a while. So with the body plot, you have a frequency and a voltage, right? And you would have something like that, right? So this is actually a low pass filter, if you forget anyway. So the inductor wise, if you were to remember, its rule states that XL is equals to 2 pi FL, right? So if your frequency is low, okay, if your frequency is low in this case, the XL is going to be low, right? Then if you remember, due to the voltage divider rule, if you're connecting the resistors, in fact this is some resistance also. So if you connect them together in series, you will get the voltage is gonna split up. So let's say this is VR, this is VL. The total V in will be equals to VR plus VL, right? And these V's are based on V equals to IR. So if your resistance over here is high, you're gonna draw more voltage, right? So it's a battle between RL and the inductor. So if this concept so let's say if I have maybe I change the color. If this RL is 500 ohm, and then if your frequency is low, definitely you have a lower impedance. You remember the lower reactance. So maybe let's say 10 ohm. So if you were to check it out, the voltage will be much higher, right? RL due to V equals to IR. So your current is constant throughout the whole circuit, right? If you remember, constant is a constant in series. So let's say if the current is 1, so the resistance will be 500, the voltage will be 500 ohm, right? While the voltage here will be 10 volts. Sorry, this will be 500 volts. This will be 10 volts. So in this case, as you can see, if the frequency is low, the voltage going through your R load is this amount high, which is about 500 volts, right? So if your frequency increases, okay, so now if your frequency increases, in this case, let's cancel these things, and if your frequency increases, proportionally your impedance is going to increase, right? So instead of the 500 ohm, right, this is 500 ohm, and then this is going to be what? Let's say when it increases already, it becomes maybe 10,000 ohm. Right? Comparatively, this is going to be damn huge, right? So if your current is still 1 ampere, okay, V equals to IR. In this case, you're gonna have a 500 volts, while you're gonna have a 10,000 volts. Okay, this is not a very good example lah. Okay, but nonetheless, if you were to compare, it should be a fraction. So it should be 500. It should be 500 divided by 500 plus 10,000. Okay, multiply by the current. Okay, this should be the case. Okay, so previously, if I were to use this VR, if you remember, is 10 ohm, right? If frequency is low, the reactance is actually 10 ohm. So it will be like 500 divided by 5 ohm times I equals to. So this is the ratio of the resistors. So in this case, if you do that, you will have a lot of voltage flowing through at this point if the frequency is low. Okay, so if doing this, okay, so let's go back to my high frequency now. So in my high frequency, I have a 10,000 reactance over here. So if you were to compare the ratio, 500 divided by 10,000, you'll get damn small number like 0.0 something, right? So in this case, the voltage This means that your voltage across your RL in this case will be much lower, 0.00 something. So as the frequency goes up, okay, you're gonna filter all the high frequencies, right? Only showing all the low frequencies area. So this is why this is called a low pass filter. You are passing all the low frequency in while isolating all the high frequency. So in this case, what can you reduce from the trend itself? Clean up a little, I show. So this is still the low pass filter. Okay, this is still a low pass filter. And then this is your frequency. If your frequency is low, the voltage across your R load, okay, across this piece of R load is gonna be high, right? And then if its frequency is high, then you're gonna have a low voltage over here, right? So how does this gyrator works? So this gyrator have to be exhibiting this type of trend in order to have a low pass, because this is actually trying to simulate a low pass filter. So in this case, now you're replacing the inductor with a capacitor and connected in this manner. So Xc is equals to 1 over 2 pi Fc, right? So if your frequency increase, let's say decrease, then in this case decrease first. If your frequency is damn small, 1 divided by 0.00000 continuous 0 equals to infinity, right? So this is the case where you have a very high impedance. High impedance or high reactance. In this case, you are going to allow it to become open circuit, right? So this is the open circuit already. So open circuit, what you're gonna do? All the voltage will flow through to the RL, right? So as you can see, if the frequency is low, all the voltage flows through this RL. So there will be a lot of voltage over here. Then it goes in. When this voltage, maybe let's say if your V is 5 volt, okay? So where everything flows in is actually 5 volts flows in, right? And then 5 volts will come out. However, since the odd nature states that you're gonna have minus and a plus to be the same volt. So in this case, right, because you're referencing to ground, right, this is actually 0 volts. So in this case, this pin over here gonna have 0 volts. So you're gonna passing through all the 5 volts out of the you're gonna pass through all the 5 volts out to somewhere else lah, okay. But nonetheless, the keynote is that you're gonna pass all the 5 volts through the RL instead of the capacitor over here. Yeah, you get me. So yes. So at the instance where you have a very high, damn high frequency, okay, if your frequency is damn high now, then if it's damn high, that means infinity, right? So 1 divided by infinity equals to 0. So in the case if this capacitor is equals to 0, you just have a plain wire. Right? You just have a plain wire. So this plain wire is gonna go through. So all the voltage now will all flow through here. It will not flow through to this IL. Right? It's because if you are this is an analogy, so if you have a road, a junction, you have a roadblock over here, then you have a straight path. Would you want to go over here and then you parkour and then you go, or you want to straight away go here and then easy? Definitely you are going this way ma. So all the voltage are thinking the same manner. I mean doing the same way. So this is why all the voltage will flow through here. So this resistance is like, yeah, it's like nothing else. So this in this case, in this manner, there is no voltage flowing through the IR anymore. No voltage. So in this case, there's no voltage over here. So this is why we have a when frequency increases, you have a 0 volts. Okay, well, I mean your voltage is gonna go down, right? So this is actually a low pass filter. Alright, so what I'm talking all about is always the low pass filter. So in this case, if it's a pure inductor, if you want to use gyrator as a pure inductor, this one will be just a simple resistance, that's all. Okay, with a yeah, I should hold on. I should clear out the little, yeah. So if it's just an inductor itself, it's just like that. So there's some resistance over here, that's all. Simple inductor. Alright, this is why if you were to drag this thing down, if you were to take a look, alright, this is, yeah, if you are connecting your capacitor and an inductor in series with your great job, there's no R load. Okay, so imagine if this is the case, right? If this is the R load, alright, if this is R load, then this whole thing is gonna be a wow. Okay, never mind. This should not be R load. I mean, yeah, there will be a R load connected over here. Okay, if you were to never watch my video, you can actually go and watch. This is actually the R load. Why? Right? This is a series capacitor inductor series, right? And then if you series parallel, you're gonna have a notch filter. This is why he puts the notch filter over here. I mean, yeah. This is a notch filter configuration. This is the, I think, the second or the third one of the notch of my series on all about, that means passive things. So if you were to take a look, right? Yeah, this is the second configuration. Alright. So you're connecting your capacitor and inductor in series, and then you connect with parallel with the R load. So this is how the same configuration works for this dude over here. Right. So if you want to replace inductor, as you can see, you can straight away place in this one over here, right? And then you set a certain resistors. So this will become a inductor. Okay. So if it's in series, you're gonna connect here over, and then this is gonna go back all the way to the beam, and then you have an R load over here. So this is where you're gonna connect. Okay, this is where you're gonna connect your amplifier. Okay, I mean your gyrator lah. So this whole thing is gyrator. So the output will be here, and then it goes all the way. So it's like that. Okay, and then so what I thought about how inductor. So basically this is simply a configuration for inductor. If you want to have a simple low pass filter, okay, you can just put RL in this manner. So what if I want a simple high pass filter? Okay, if I want a simple high pass filter, what I'm gonna do is I bring this over here, and then just a warning lah. Okay, I may be wrong. Okay, I may be wrong. But if I were to do that, okay, it sounds logical. So if I were to place a capacitor over here, okay, one more capacitor over here, I would change the whole system. Alright, I would allow my my trend to go like this. Okay, so what does this mean? My fault. I'm wrong. But in this case, I think I may be correct lah. Let's do it again. Okay. So in this case, if I were to change the whole diagram, instead of a capacitor over here, I bring the capacitor over here, and then I input a new resistors over here. What I'm gonna do is actually to implement a high pass filter. So if I have a low frequency, okay, Xc equals to 1 over 2 pi Fc, right? So if I have a low frequency, 1 divided by 0.000001, right? I mean, maybe perhaps like if I have a zero frequency, okay, I have infinity gain. I mean infinity resistance, right? Reactance over here. So let's say this is now infinity ohm, and this is like maybe 10 ohm, right? The R load. So if you know that if you connect in series now, V equals to IR. So your resistance will play a very huge part. So 10 ohm divided by infinity, alright, you'll get almost 0 voltage. Okay, 0 ohm. Right, so in this case, at RL, this is the ratio, right? Yeah, this is the amount of voltage you can take in, which is meaning you're taking a very little voltage now. So this is R times I goes to volt, right? So this is the ratio between the RL and the total of RL plus the reactance of the capacitance. So in this case, yeah, right. So 10 ohm plus infinity, right? Then multiplied by VI equals to V. So in this case, this 10 divided by infinity, you're gonna get 0 ohm. So you're gonna have a 0 volts. You're gonna have 0 volts. So in this case, if the frequency is low, okay, your capacitance is gonna take in all the voltage. So you leave very little voltage for your RL. So this is why your RL over here is 0. Okay. So if your frequency now, let's change the story. If your frequency now is increases, alright. If your frequency now increases, what do you have? Okay, you will have x 1 divided by infinity. If your frequency is infinity now, so 1 divided by infinity equals to 0. So you have a 0 over here. Alright. Now if my frequency increase, okay, now if my frequency increase, what do I have? I want infinity over equals to 0, right? So in this case, my capacitance here is 0 ohm. So I mean not capacitance, but rather than the reactance, or yeah. So all the voltage will pass through. So this one will act like a piece of wire now. So all the voltage will flow through, and then will go through the RL. So the amount of voltage, all the voltage will flow into RL in this case. So this is why you have a high frequency, you will have all the voltages at the very high part. Alright, so you may wonder why I put in the resistors over here. The reason I put in the resistor over here is that if I leave it just like a wire, okay, if I were to leave it like just like a wire, the voltage will not flow here. The voltage will all the way flow here, and then there's no meaning in that, right? So you need a certain resistors to actually prevent the voltage from going here, or rather than going here, right? But nonetheless, I may be wrong, okay? I may be wrong if you want to connect in this manner, okay? If you want to connect in this manner, because they didn't, in the book they didn't say anything. So this is what I spawned out, because they only provide you with a low pass. Okay, they only provide you with this one only, that's all. Alright. So for the high pass, if you remember the high pass, I'm connecting the inductor over here, and then I put it like that. Right. So it's a totally different thing. But nonetheless, just now that one, I would believe that it works lah. But however, if you want to have another configuration for your high pass filter, what I would recommend is that right, since you know that you're connecting your inductor in this manner, this is the high pass configuration, okay, just to balik. Alright, so in this case, if I were to do that, you know that the inductor itself by itself, okay, you can configure it in this manner, right? And then this is the output I can connect to my resistors R load. I can connect like that also. So in this case, as you can see, this is a series now, right? So I have a R load connected up over here. So you can, alternatively, you can draw like that, or otherwise you can draw capacitor, and then like that. And then I have a resistors, and then this is connected to ground. What the hell? Where am I? And then I have a feedback over here, and this is the thing. Okay, so I'm just simply putting bring up this capacitor over here, and then I implement another resistors. Alright, so these are the two configurations. This is the first configuration. This is the second configuration, which is what I spawned out. I may be wrong. So I'll see you in the next video for the limitations of a gyrator. Okay, this is the things that because I have no time already. So see you there. Bye bye.